This question discusses the Ebola virus. We are told the Ebola virus has an incubation period that is normally distributed. It has a mean of 12.7 days and a standard deviation of 4.3 days. Now, question A says, emergency health workers in a particularly affected area are trying to manage an outbreak with 1,200 suspected cases of Ebola that are not yet symptomatic. They isolate all 1,200 people for 21 days and release anyone after that period who still shows no symptoms. Assuming the worst case scenario that all 1,200 cases are infected, how many can we expect to last the entire isolation period with no symptoms, but still show symptoms later? The key word here is expect. When we see the word expect, we want to think about expected value. Now, the definition of expected value is n, the size of the sample, times probability. Now, we know that the size of the sample is 1,200 people, but let's think about what we mean by probability. What this passage is discussing are people who last more than 21 days without showing symptoms. Let's think about what that would look like in a drawing. We begin by drawing our bell curve. Our mean is going to be the mean number of days. This was given to us as 12.7. We have a standard deviation of 4.3 days. So 21 days is significantly higher than the mean, and it will be far to the right. We are interested in the people who take more than 21 days to show symptoms. Now remember, more means go to the right. So what we are trying to find is the probability of being in that tiny red region on the right side. Now remember, if we're trying to find probability in a normal distribution, but we know the x value, what that means is we'll use norm dist. And let's recall that we'll enter x, mean, standard deviation, and true. Anytime you need to find a probability as your answer or part of your answer, we want to use norm dist. Let's first enter that data into Excel. We'll enter x, a mean, a standard deviation, and then based on that we'll get the probability of being less. However, if we check the picture, we're not interested in the part that's less, we're interested in the part that's greater. Since we've shaded to the right, we will have to include an additional step and say that p greater is 1 minus p less. Keeping in mind that Excel always does less as part of the norm dist formula by default. Now our x is 21, our mean is 12.7, and our standard deviation was 4.3. Now that we've entered this, we can do the norm dist formula. We'll click x, comma, mean, comma, standard deviation, comma, true. Now our probability of being greater is equal to 1 subtract p less. This gives us a probability of being greater of 0.02679. Now, we need to get the expected value as well. Let's remind ourselves that expected value was n multiplied times probability. So let's also enter our n into Excel. Based on this, we'll get our expected value. Our N was 1,200. And let's remind ourselves our expected value, or EV, is equal to N times P. Again, we want P greater, not P less, because we shaded to the right side on the graph earlier. So we'll say equals, click the P greater, and multiply times N. We'll do this anytime we're doing expected value. If we round this, we would expect 32 people to be infected out of the 1,200. This will be the answer to this problem.